If you've spent any time looking at global ecosystems, you know just how incredible the diversity is out there. But have you ever really thought about the clever systems scientists use to kind of decode how all that life is spread out? Today, we're going to take a deep dive into biogeographical classification. Basically, how experts bring some order to the beautiful chaos of biodiversity.
Yeah, exactly. And our mission really is to unpack these frameworks, ecozones, biomes, ecoregions. These aren't just fancy academic terms, they're fundamental tools. They let us study, manage, and I think most importantly, conserve the planet's life, especially with everything changing so quickly.
Right. For anyone tracking biodiversity, it's clear it's not just what species are out there, but where they are and, crucially, why they're there. And biogeography, well, that's the science that maps this. To make sense of it, ecologists set up this hierarchy for the biosphere. That living layer of Earth where life interacts with the ground, the water, the air.
And what's really fascinating is how this hierarchy works. It moves from these truly vast scales down to the very specific. And it integrates both the living and the non-living parts of the environment. So at the very top, the broadest scale, we have ecozones. Sometimes people call them biogeographic realms. Think of these as the grandest divisions, shaped over millions, truly millions of years. They're like these giant evolutionary cradles, defined by the deep history of their plants and animals. Things like continental drift, massive physical barriers, oceans, huge mountain ranges, they shape these ecozones. For instance, the neotropical ecozone, covering Central and South America. Its long isolation made it the most biodiverse realm on Earth, a real testament to evolution over time.
Wow, millions of years. That continental scale gives you a really deep historical perspective. But I guess some might say those hard lines, maybe they don't capture all the mixing that happens today. Are there sort of fuzzy edges where these ecozones meet, and how do we get a view that's maybe more focused on today's ecology?
That's a great point. Ecozones give us that deep history, but maybe not the day-to-day ecological story. So that's where biomes step in. Biomes are large biological communities. They're defined mainly by their dominant vegetation type and the climate that supports it. Temperature and precipitation, those are the key drivers. And here's a really crucial difference. A single biome, like say deserts or maybe tropical rainforests, can actually pop up in several different ecozones. Think about the Sahara Desert in the Palearctic ecozone and the Atacama in the Neotropics. Totally different evolutionary histories. But they're united by similar arid conditions and the kinds of life adapted to survive there. They share ecological functions, not necessarily common ancestors.
Okay, that makes sense. So it connects ecology and climate, not just that deep, deep history. So if biomes are about climate and plants, where does the real focused action happen, especially thinking about conservation work?
Right. That's where ecoregions become so important. These are more detailed, finer grain, you could say. They're typically large areas, yes, but they have a really distinctive mix of species, unique environmental conditions, and often really high levels of endemism. That means species found there and absolutely nowhere else. They often contain multiple different habitat types within them. The Choco-Darien region, for example, spanning parts of Ecuador, Colombia, Panama, it's famous for its superhumid rainforests. Just an incredible hotspot of biodiversity, loads of unique species, many sadly endangered. Or, think about the dry, deciduous forests in Madagascar. Totally unique, defined by its seasons, and of course the lemurs you only find there.
Okay, so we've gone from these ancient, massive continents through climate-driven communities right down to these unique biological hotspots. But what's the bottom line? Why does understanding this hierarchy actually matter for us, for the decisions we make?
While connecting it to the bigger picture, this whole classification system is absolutely fundamental for doing conservation effectively. It helps us identify critical gaps in conservation, finding important areas that aren't properly protected yet, maybe some mountain ranges in Central Asia or vital chunks of the Amazon. And it's not just finding hotspots. These maps are actually vital for things like predicting how invasive species might spread, or even tracing where a disease might have originated by looking at host animal distributions. It also really starkly highlights how human-dominated landscapes are a huge driver of the biodiversity crisis. We have to factor that into planning. Now, look, these systems aren't perfect. Of course not. There are overlaps, challenges. Sometimes we lack good data globally, and it's tough defining boundaries when climate change is shifting everything around. They're dynamic tools, not set in stone.
So we've really explored how scientists map out life on Earth, from those vast ancient ecozones through the climate-shaped biomes, right down to the very specific and often vulnerable ecoregions. It's quite a system, really a shortcut to understanding the complex living tapestry of our planet.
And this brings up a really important question, doesn't it? Given how dynamic everything is, with climate change, human impacts constantly reshaping things, how do these classification systems themselves need to adapt? How do they need to evolve so we can actually ensure the survival and well-being of all species going forward? What really strikes you about the power of just knowing where life lives?